According to the National Electrical Code, 10-volt DC-controlled ballasts typically fall under Class 2 wiring methods. Class 2 circuits are defined by specific characteristics aimed at ensuring safety and limiting energy in electrical systems. The NEC specifies criteria that the circuit must meet to be classified as Class 2. These criteria primarily concern voltage and current limitations, designed to minimize the risk of electrical shock and fire. Firstly, the voltage of a Class 2 circuit must be less than 15 volts alternating current AC or 30 volts direct current DC. This voltage limitation is a fundamental aspect of Class 2 circuits, ensuring that the potential for electrical shock is significantly reduced. Secondly, Class 2 circuits must be limited by a transformer or another suitable device to a current of not more than 5 amps. This current limitation is crucial for preventing overheating and potential fire hazards in the event of a fault or short circuit. Thirdly, Class 2 circuits are typically used for low-energy applications. Examples of such applications include lighting, signaling, communication, and control systems. These applications generally require low power levels and do not pose a significant risk of electrical hazards. The Universal ES-1 CFH-42/32/26 UNVHC-DIE-10 ballast, which operates at 10 volts DC and is designed with current-limiting features, aligns with the characteristics of a Class 2 circuit as defined by the NEC. Given that it adheres to the voltage and current limitations specified for Class 2 circuits, it is appropriately categorized under Class 2 wiring methods. Class 2 power supplies are designed with built-in safety features to limit the voltage and current to safe levels. These power supplies are crucial components in ensuring that Class 2 circuits adhere to the NEC requirements. The NEC provides detailed guidelines and specifications for Class 2 wiring methods, including conductor sizing, insulation requirements, and overcurrent protection. Compliance with these guidelines is essential for ensuring the safety and reliability of Class 2 circuits. The NEC Article 725 covers the requirements for Class 2 and Class 3 remote control, signaling, and power-limited circuits. This article provides detailed information on the installation and wiring of Class 2 circuits, including conductor types, overcurrent protection, and separation from other circuits. When installing or working with Class 2 circuits, it is important to follow the NEC guidelines carefully to ensure compliance and safety. This includes using appropriate wiring methods, providing adequate overcurrent protection, and properly labeling the circuits. Understanding the NEC requirements for Class 2 circuits is essential for electrical professionals and anyone working with low-voltage electrical systems. By adhering to these requirements, it is possible to minimize the risk of electrical hazards and ensure the safe and reliable operation of these circuits. Some additional considerations regarding Class 2 circuits are that Class 2 circuits must be physically separated from other power circuits to prevent accidental contact or voltage induction. This separation can be achieved through the use of barriers, enclosures, or by maintaining a specified distance between the circuits. Class 2 circuits must be clearly identified and labeled to distinguish them from other types of circuits. This labeling helps prevent accidental misconnections or modifications that could compromise the safety of the system. It is important to verify that all components used in a Class 2 circuit, including power supplies, conductors, and connectors, are rated for the appropriate voltage and current levels. Using components that are not properly rated could lead to overheating, failure, or other hazards. Regular inspection and maintenance of Class 2 circuits are essential for ensuring their continued safe and reliable operation. This includes checking for loose connections, damaged insulation, and other signs of wear or degradation. When making any modifications or repairs to a Class 2 circuit, it is important to disconnect the power supply and follow appropriate safety procedures. This helps prevent electrical shock and other hazards. The NEC also addresses the use of Class 2 circuits in specific applications such as fire alarm systems, HVAC controls, and security systems. These applications may have additional requirements that must be followed to ensure compliance with the NEC. Understanding the specific requirements for each application is essential for ensuring the safety and reliability of the system. When selecting a Class 2 power supply, it is important to consider the voltage, current, and power requirements of the circuit. The power supply should be sized appropriately to meet the demands of the circuit without exceeding its rated capacity. It is also important to consider the environmental conditions in which the Class 2 circuit will be operating. This includes temperature, humidity, and exposure to moisture or corrosive substances. Selecting components that are suitable for the environment will help ensure their long-term reliability. The NEC is updated on a regular basis to reflect changes in technology and industry practices. It is important to stay up to date with the latest edition of the NEC to ensure compliance with the most current requirements. The NEC is available for purchase from various sources, including the National Fire Protection Association (NFPA). Training and education are essential for electrical professionals who work with Class 2 circuits. This training should cover the NEC requirements, safety procedures, and best practices for installing and maintaining these circuits. There are many resources available for electrical professionals who want to learn more about Class 2 circuits, including online courses, seminars, and workshops. Taking advantage of these resources can help improve your knowledge and skills and ensure that you are able to work safely and effectively with these circuits. The NEC defines Class 3 circuits which are similar to Class 2 circuits but allow for slightly higher voltage and current levels. However, Class 3 circuits are subject to more stringent requirements than Class 2 circuits. Class 2 circuits offer a balance between safety and performance, making them suitable for a wide range of low-voltage applications. By understanding the NEC requirements for Class 2 circuits and following appropriate safety procedures, it is possible to minimize the risk of electrical hazards and ensure the safe and reliable operation of these circuits. The specific requirements for Class 2 circuits can vary depending on the application and the local electrical codes. It is important to consult with a qualified electrical professional to ensure that the installation meets all applicable requirements. The NEC provides tables and examples that illustrate the application of Class 2 circuit requirements in various scenarios. These resources can be helpful in understanding the practical implications of the NEC. The NEC also addresses the use of Class 2 power extenders, which are devices that allow Class 2 circuits to be extended beyond their normal length limitations. These power extenders must meet specific requirements to ensure that they do not compromise the safety of the circuit. When using Class 2 power extenders, it is important to follow the manufacturer's instructions and the NEC requirements carefully. This will help ensure that the circuit remains safe and reliable. The NEC also addresses the use of wireless technology in Class 2 circuits. Wireless technology can offer a convenient way to control and monitor Class 2 circuits, but it is important to ensure that the wireless system meets all applicable safety requirements. The NEC requires that wireless systems used in Class 2 circuits be properly tested and certified to ensure that they do not interfere with other electrical systems or pose a safety hazard. When installing a wireless system in a Class 2 circuit, it is important to follow the manufacturer's instructions and the NEC requirements carefully. This will help ensure that the system operates safely and reliably. The NEC also addresses the use of fiber optic cable in Class 2 circuits. Fiber optic cable offers a number of advantages over traditional copper wire, including immunity to electrical noise and the ability to transmit data over long distances. However, fiber optic cable must be installed and terminated properly to ensure that it functions correctly and does not pose a safety hazard. The NEC provides specific requirements for the installation and termination of fiber optic cable in Class 2 circuits. When working with fiber optic cable, it is important to follow these requirements carefully to ensure that the system operates safely and reliably. The NEC is a complex and comprehensive document that covers a wide range of electrical topics. It is important to consult with a qualified electrical professional to ensure that you are following all applicable requirements. The NEC is not a substitute for proper training and experience. It is important to have a thorough understanding of electrical theory and practice before working with electrical circuits. The NEC is a living document that is constantly being updated to reflect changes in technology and industry practices. It is important to stay up to date with the latest edition of the NEC to ensure that you are following the most current requirements. The NEC is an essential resource for anyone working with electrical circuits. By understanding the NEC requirements and following appropriate safety procedures, it is possible to minimize the risk of electrical hazards and ensure the safe and reliable operation of electrical systems. The information provided in this narration is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrical professional before making any changes to your electrical system. When working with electrical circuits, it is important to use appropriate personal protective equipment, PPE, such as safety glasses, gloves, and insulated tools. Always disconnect the power supply before working on any electrical circuit. Never work on electrical circuits when you are tired or distracted. If you are not sure how to do something, ask for help from a qualified electrical professional. Electrical safety is everyone's responsibility. By following these safety tips, you can help prevent electrical accidents and injuries. Remember to always check your local electrical codes and regulations as they may differ from the NEC. Also remember to stay safe and be aware of your surroundings when working with electricity.